Question 2 wasn't on the AS paper, but it was on the homework that you just did last week, and so I thought it was a fair question. And what we wanted to see was a nice diagram to begin with. So I'd want to see the weight on here. The weight is mg. I'd want to see the normal reaction coming up here. And a few people thought that the normal reaction R would be equal to mg, but it's not, because we've got this force pushing down as well. This thing's trying to move off to the right, so there's some friction stopping it here. I'm going to put my friction on like this. And the other thing I've got to do is split this force that's coming down at an angle up into its two parts. There's a bit going down and there's a bit going to the right. That going down is next to the angle here, so I've got 100 cos 30, and this bit here is opposite the angle, so here I've got 100 sine 30. Having got your diagram sorted, we now want to look in each direction. Let's look at what forces are pushing it to the right. To the right, I've got 100 cos 30, but I've got the friction stopping it. And that will equal the mass times the acceleration. The mass is m, and the acceleration, well, some people looking around for that, but look, here's the words, it's got a constant speed, so the acceleration is 0. So from that equation, I can deduce that the friction is 100 cos 30. And I'll stop there for a minute with that one. What I'm going to look at now are the forces going upwards. The force going upwards, I've got R. I've also got minus mg, because it's going in the opposite direction. And I've also got minus 100 sine 30. And that's going to equal 0 as well. Not because it's moving at a constant speed, but because it's actually not moving at all. It's not going up or down. So that equals 0. So from this one here, I can tell you that I can tell us that R is equal to mg plus, and you know what, I'm going to tap that in the calculator because I do know that 100 sine 30 is equal to 50. And so I've now used my two force equations and I'm going to join them together because I know the rule is friction equals mu R. And the friction is 100 cos 30. 100 cos 30, I've got that as 50 root 3 here. Mu, we were told in the question, I've moved it up there, but it's a half mg plus 50. So I've just got to do some rearranging now then. I'll times it by 2. I'll take away the 50. And finally I'll divide by g. And the answer when I get all of that is 12.57, blah. One last thing to do is we need to round this to 12.6 kilograms. If you left it like this, it was considered too accurate